Okay, so this video will be a introductory video for College Prep Math 3 Module 3 Lesson 2. It's all about factoring today. Before we get into what factoring is and how it works, just a quick review of some skills that we'll need to know. Sometimes in the past we've seen these binomials. X plus 3 has two terms, x plus 4 has two terms, a couple of binomials that are multiplied together. We dealt with these. Some people call it the FOIL method. I just kind of think of it as distributing this x across the parentheses. So x times x is x squared, x times 4 is 4x, and then distributing the 3 across the parentheses. So 3 times x is 3x, and 3 times 4 is 12, and then we can combine those like terms in the middle. And when we multiply these two binomials together, in a lot of cases, what we're going to wind up with is a trinomial. Okay, so what the point of this lesson is to reverse this process. We're going to start down here with a trinomial, okay, and we're going to learn some strategies for how to take that trinomial, break it apart into a couple of binomial terms that are multiplied together. And important skill because when we have simpler pieces that are multiplied together, there's going to be a lot of different strategies that we can use to get information from those, let us solve problems. Okay, so the good news for us with the questions in this particular section is they're all going to be fairly straightforward. Now, what you'll notice here first is that this is a trinomial, right? So that's the general form of the polynomials we're going to be working with in this module. We're going to have 3 terms in most of them. And you'll also notice here there's no leading coefficient. Our implied leading coefficient in this term is a 1. The methods that we're going to learn today, you really have to have a 1 in the front. You can certainly factor some polynomials if you have a number bigger than the 1 in the front, but it is more complicated and it's just something we're not going to worry about in this particular section. So you'll notice here we have a trinomial with a leading coefficient of 1, and that is good. That's the kind of setup that we want to use the strategy we're going to learn today. Okay, so the next thing I'm going to do is I'm going to come out to the side and I'm going to set up an x here that I'm going to fill in with some information from the problem to let me figure out how this factors. Okay, so first thing I'm going to note here is that my last term is a 12. I'm going to put that up top here, okay, and my middle coefficient here is a positive 7. I'm going to take that positive 7 and I'm going to put it down below. Okay, so the way that I'm going to figure out how to factor this, how to break it down into those two binomials like we saw in the problem on the last page, is I'm going to look for two numbers that multiply to give me this number up top here and add to give me this number down here. And this is where you have to practice some. And hopefully people have a pretty good grasp on their multiplication facts because you really just have to think about your different possibilities, right? I'm looking for numbers that multiply to give me 12. So if I'm thinking about those options, I can do 1 times 12. But if I add those, I don't get 7. So that's not the one I want. I can do 2 times 6. Right? Again, if I add those, I don't get the 7 that I want. So that's not the pair that I want. And then I know I can do 3 times 4, right? 3 times 4 is 12. 3 plus 4 is 7. And so those are the numbers that I'm going to want to put on the sides of my x here. Okay. I also want to make sure I'm thinking about the signs of these numbers as I'm going through this process, right? And that we know a couple of things about these numbers. If I want to multiply two numbers together and I want to get a positive 12, there's a couple of ways that I can do that. I can multiply a positive times a positive or a negative times a negative. So I know from this number up here that my signs are the same. This plus sign right here is going to tell me that that's the case. This plus sign at the end tells the signs of these two numbers are the same. And then I also know that I need these things to add, to give me a positive 7, okay? And again, I know my signs are the same, right? I want them to add to give me a positive 7. Well, if you're going to have numbers with the same sign, they're going to add to give you a positive number. They both have to be positive, okay? So that's what this one over here is telling me. There are some shortcuts for these, and we'll kind of go through these as we see some different cases in this lecture. But this one right here, in general, if it's a plus, it tells me that the signs are the same. For that particular case, this one tells me what my signs are. So this one tells me that they're the same, and this one over here tells me that they're both positive. Okay, and so once I've got this set up, this is my work. The x over here, this is where my work happens for this particular problem. Okay, once I have that x done, then putting this together is pretty easily done. To get the x squared in the front, I know I need an x in the front of both of these. It's the only way to make x squared. If this is not a 1 in the front here, this is more complicated. But again, like I was saying, this is going to be the kind of problem we're working with, a 1 in the front. So x and x in the front. And then my numbers from my work over here, they're just going to go right into the second part of both of these parentheses. So x plus 3 times x plus 4 is my factored form. Okay? All right, so let's look at another example. This is another trinomial. We've got the x squared, the x, and the 12. We've got those 3 separate terms, right? And our leading coefficient over here is a 1. So once again, we're set up in this same form. When we have this kind of a setup, then what I'm going to do is I'm going to come out to the side. I'm going to set up my x, my minus 12. I'm going to put that up top here. And then my middle coefficient, there's not one written here. The implied coefficient on that then is a 1. So I'm going to have a negative 1 down below. And so what I'm looking for here are two numbers that multiply to give me negative 12 and add to give me negative 1. Okay, and got to be a little careful on this one. Because of that negative sign on the minus 12, it does tell me that it's going to work a little different. When I'm adding these numbers, the only way that I can make a negative x with multiplication here is if my signs are different. Okay, so I'm going to have a positive or a negative one of each on my outsides here. And so when I add numbers with different signs, I actually subtract them. So really what I'm looking for in this particular problem, because of this minus right here, is I'm looking for two numbers that multiply to give me 12 and subtract to give me 1. And again, if you're not seeing it, just make a little list. Come down here. Think about the ways you can multiply numbers to get you 12. 12 times 1 is 12. 12 minus 1 is 11. That's not what I want. I could do 6 and 2. 6 minus 2 is 4. Again, that's not what I want. But finally, 4 times 3, you'll get better at this as you do it more. You maybe won't have to write this list when the numbers are fairly straightforward like this. But we know 4 minus 3 is 1. So 4 and 3 are going to be the numbers that I'm going to be working with here. Okay? And so then I've got to really think about the signs of these two numbers, because 4 plus 3 is 7. It's not what I want. I want my signs to be different, like I mentioned earlier. So which one is which? Which one is positive and which one is negative? Well, this sign right here in this particular case is going to tell me the sign of my larger number. So 4 and 3 are my two numbers. In this case, since my middle coefficient is negative, this is going to be a negative, and that means the other one's got to be a positive. Okay, and once again, this is your real work for the problem. You know, this is a pattern you have to practice to get down. Okay, and this is where all of your work happens, is in this x. Once you get this done, then putting these parentheses together are very easy, as long as your leading coefficient is a 1, which is going to be the case for this whole lesson. Okay, we know that to make this x squared, we need an x and an x, and then our work over here, the negative 4 and the plus 3, those are just going to go right in, and there's our factored form. Okay, but once again, you really have to think about the signs as you're going through this. You want to make sure that you multiply to give you negative 12 up top, and you add to give you that negative 1 on the bottom. That's what we're looking for there. Okay, so let's look at one that's slightly different now. So if I'm looking at this problem right here, the first thing that jumps out at me is that I don't have a 1 in the front here. And so that's going to be different from what we're working with in the rest of these problems. But what I can't do here is I can't forget the first step to factoring that we learned in lesson 1. And that is, if there's something in common in all of your terms, you want to take it out. In fact, this is really the first thing you should be thinking about with every factoring problem is there a greatest common factor that I can pull out of those? And if I look at I don't have any x's, like this third term over here doesn't have any x's in it, right? So I can't work with that. But there is something that goes into all of our coefficients. So we have a GCF in this. Can't forget that from our first lesson. Our GCF here is 3. So our first step, before we even think about setting up our x or doing our two parenthesis things, is to look for a GCF, and if there is one, we pull it out. So I'm going to pull that 3 out to the front. Okay, I'm going to divide every term by 3 to see what's left. 30 divided by 3 is 10. 48 divided by 3 is 16. Okay, and once I've got that GCF taken out, what I've done here is I've made a trinomial that looks very similar to the last couple of trinomials we were working with. Okay, I've got that leading coefficient of 1. And so that is what I'm going to continue to work with here to continue my factoring process. I'm going to set up my x like we've done in the last couple of problems. I'm going to look for a couple of numbers that multiply to give me 16 and add to give me 10. Again, if you're not sure, if it's not jumping off the page at you, then what you want to do is you want to start making a list of factors for 16 until you find the pair that does what you want. In this case, 8 times 2 is equal to 16, and 8 plus 2 is equal to positive 10. So I can put those right in now. And now my signs are the same. Again, this is kind of a nice reminder here. This one tells me that my signs are going to be the same. And in that case, this one's going to tell me what they are. So positive 8 and positive 2 are going to be my numbers. Okay. And again, this is where most of the work for this factoring process happens. Okay. I'm just going to break this, just the parenthesis down based on our work over here. We know to make this x squared in the front, we need an x and an x. And then positive 8 and positive 2 are the numbers we got from our x over here to the right. And then the final step here is to make sure you don't lose your GCF that you pulled down. When we're factoring, we need to make sure we bring that down, and it's certainly going to be part of our answer. So we will have some problems in this lesson where we are having a couple of steps to our factoring. Sometimes we have to take the GCF out. And then once we take that GCF out, our next step is to look at what's left over and see if we can continue to factor. In this case, we were able to factor that because it was a trinomial with a leading coefficient of 1. Okay, so a couple steps to that one. Okay, so let's look at one last example here on these problems. Again, I've got another trinomial. I've got my 3 terms here. Again, my leading coefficient is a 1. So there's no GCF in this one. So I want to go ahead and set up my x to the outside here. And what I'm looking for here are 2 numbers that multiply to give me negative 8 and add to give me positive 6. And a lot of people's first instinct here is going to be to go with like 4 and 2 because 4 plus 2 does equal 6 when we add them. 4 times 2 is equal to 8. But we got to be a little careful on this because we have to pay attention to our signs. The signs are where people really get tripped up on these things. Because of this minus right here on the 8, what we're looking for is we're looking for 2 numbers that multiply to give us 8 and then subtract to give us 6. To make a negative 8 with multiplication, we have to have different signs. It means we're going to subtract them to give us 8. And if we think about our possibilities here, we can do 8 times 1 to get 8. 8 minus 1 is 7. And we can do 4 times 2 to get 8. 4 minus 2 is equal to 2, right? So neither one of those possibilities give us the 6 that we want, okay? And we're only going to catch that if we're paying attention to our signs. It's going to be an important part of this lesson. So this x, it's just not something that's going to work out for us. We're not going to be able to fill that in, okay? This is not unusual, and it's something that you want to be prepared for, okay? Because, even though we've done 3 or 4 of these examples already in this lesson and they've all factored, many polynomials do not factor, okay? We call these polynomials prime polynomials, okay? This is an example of that, okay? So we set up our x, we thought about our signs, we tried all of our possible combinations, and none of them worked. If you're unable to find a pair of numbers to fill in with your x here that work for your factorization, you're looking at a prime polynomial, okay? And you'll notice on all of your My Math Lab questions, you have a B option there for the polynomial being prime. You want to make sure you're going through the process and only using that where it's appropriate, right? But some of them will be prime. This one is definitely a prime polynomial. It just means it doesn't factor, okay? So you want to be ready for that as well. So hopefully that's enough to get you off to a good start. I would warn you that factoring is very difficult until you get it, and then it's kind of a light bulb topic is what I like to call it, because it's one of those things where you have to practice until you get the patterns down. It's not a matter of doing a bunch of steps. It's a matter of doing the patterns until they start to click and you start to see them, Okay, so it is something that will maybe take a little more practice than some of the other things that we've done, but it's very much worth it if you do that practice, because once you get there, this stuff is pretty nice. It's not too bad. Just you have to practice enough until you get it down. Okay, so hopefully you'll be able to do that. And if you're struggling, please let me know. I'm happy to help. Shoot me an email through Ask My Instructor. All right, you all have a good day.